Hello guys, today we are going to do the inverse Laplace transform of our s over parentheses s² + 1 times parentheses s+1. And here's, I'm going to use the compact partial fractions this time, and I'm not going to use, and whenever you see the s square, yes, the power is square, we should use our as plus b. And the variable here is s, so we are going to use s, and the over s² + 1 plus, when the power is first power here, s+1, which is our another constant c. I'm not going to use this method here. I'm going to use the compact partial fraction, which means the compact partial fractions. And let's start. So first I'm going to write this s² + 1 here, which is equal to our s² minus I² times s+1. And then because I² is -1, minus become +1, so it's just the original s² + 1 here. Doesn't change anything. And then here I'm going to write this by the identities something square minus something square, which is equal to our s on the top, and then s minus something times s plus something. So this s minus I times s plus I here. And then you can see every single of these three expressions they have the first power here. First power is really easy. Just use our cover method. How can we do this though? Cover method. So you can get each of these fractions, their top gonna be just a constant with no variable. Just a constant. And here, how can we do this? How can we figure out what's the numbers above s minus I? First, we are going to cover up the numbers s minus I here. How can we let s equal to 0? Yes, s need to be equal to I, positive I. So put I on the rest of that. So you can get I over I plus I times our, I'm going to write this as 1 plus I here. And then I plus I, which is equal to 2I, and then I and 2I get cancelled. So we can get, and then here we are going to multiply with the conjugate of 1 plus I, which is 1 minus I. And then here you can get 1 over 2 in front, cancelled I and 2I, and then times 1 plus I times 1 minus I, which is 1 square, which is 1 minus I². Then top you get 1 minus I. Here, 1 minus I², which is 1 minus 1. So this is 2. 2 times 2, which is, yes, 1 over 2 times 1 over 2, which is 1 over 4. We can write this as 1 minus I over 4. So the first numbers, yes, the number above s minus I, which is equal to 1 minus I over 4. And then the second one, how can we figure out what's the number above s plus I? Cover up this s plus I. How can we let this equal to 0? So s need to be equal to -I. So put -I on the rest of this. So -I minus I, which is -2I. And then 1 minus I here. -1 minus I plus 1, which is equal to 1 minus I. And here, do the same thing. But this time the conjugate, which is 1 plus I. The conjugate of 1 minus I, which is 1 plus I. And then we cancel out negative sign and I. You can get a positive 1 over 2. Once again, just like this. And then this 1 minus I times 1 plus I, which is just 2. Already done that. And then 2 times 2, which is 4. And then the top you get 1 plus I here. So the constant, which is 1 plus I over 4 on top. And finally, how can you figure out what's the constant above s plus 1? Cover of s plus 1. How can we let this equal to 0? Yes, s need to be equal to -1, and put -1 on here. -1 over -1 minus I times our -1 plus I. And here, take a negative side outside and then get cancelled this negative side, so you can get 1 over 1 plus I times I minus 1. I minus 1, we can write this as, yes, you can switch the order of it. I minus 1, which is negative 1 minus I, like that. So I'm going to take a negative side outside and then 1 minus I here. And then already done that, 1 plus I times 1 minus I, which is equal to positive 2. So this is negative 1 over 2. So the numbers above s+1, which is equal to negative 1 over 2. And then I'm going to take a Laplace transform of this real quick. Take the constant outside, 1 minus I over 4. And then how can you take the inverse Laplace transform of 1 over s minus I? So this 1 over s minus something. So it's gotta be e power of I. That's something times t. And then that's here. You can get 1 plus I over 4 times e, also e. But this time you can write this I as minus negative I. So this is negative IT. And then finally, this you can write this one as negative minus negative 1. So this is here we can get a negative 1 over 2 times our e power of negative t. And then here, this seems like this is a complex solutions, but no. The inverse Laplace always give you a real solution. So this never can be imagined. So we are going to simplify these expressions. This is real and this is also real. I'm going to show you. So first, I'm going to expand this. I'm going to write this as 1 over 4 times it minus I over 4 times e power of it. Expand it plus 1 over 4 times e power of negative it plus I over 4 times e power of negative it minus 1 over 2 times e power of negative t. And then I'm going to just combine the real part and the imaginary part. So the real part here is 1 over 4. And I'm going to write this as 1 over 4 as our 1 over 2 times 2. And then e power of it. And then here, which is plus e power of negative it. And then here, I'm going to put the I outside, which is plus I over 2 times 2. And then here, this minus this, right? So you can get e power of our negative it minus e power of it. And then minus 1 over 2 times e power of negative t. Like that. And then here, what can we do here? And here, e power of something. E power of something plus e power of negative something over 2, which is equal to our hyperbolic functions. This is our quash. I pronounce this as quash. And then here, you can get 1 over 2 times quash it here. And here, e power of something minus e power of negative something over 2, which is equal to I sinh I times sinh x, like that. No negative sign here, but this time this is negative e power of negative something minus e power of something positive. Therefore, we need to take a negative sign and then switch the order. So we can get a negative sign here. So we can get negative I over 2 times another I, and then sinh. No, what am I doing? Let me just, yeah. I skipped the steps, I think. I'm not going to skip the step here. No, I didn't. Just continue. This should be equal to sinh x, like that. The negative side is right. And then just need to do that. Take a negative side outside, yes. Switch the order and then take a sinh it minus 1 over 2 e times e power of negative t. And then what should we do next? And then quash, use the identity. Quash I x, which is equal to cosine x, and then our sinh I x, which is equal to positive sine I sine x. positive I psi x. Remember this. So we are going to get our. I think I need to check the identity. Since ix, I kind of forget about it. I haven't do the hyperbolic functions for a long time. Yes, positive I psi x. So we can write this as our cosine t, and then minus I over 2, and then this sinh, which is I psi t, minus 1 over 2 times e power of negative t, and then I times I, which is positive, so we can get our positive. We can write this as 1 over cosine t plus 1 over 2 sine t minus 1 over 2 times e power of negative t, which is the Laplace transform of this question. So these are our answers, and thanks for watching, and stay tuned for more videos, and bye. 11 minutes, really long, yeah.